Okay, this is the first lesson for Law of Sines, and this is 5.5. I really like these two sections. They talk about triangles that don't necessarily have to be right triangles, and everything else that we've done really has had to be a right triangle. So we're going to think back for a second. We're going to think back methods of proving triangles congruent. So see if you can take a second and think or write down the 5 ways to prove triangles congruent. Okay, so we have 5 of them. We have HL, which is hypotenuse leg. We have SSS, SAS, AAS, and ASA. So those are the 5 methods to prove triangles congruent. Okay? Determining which method we have is going to determine how many triangles we're going to actually be able to make. So now we're not going to consider HL because HL is for right triangles, and all the ones that we're going to talk about are going to be any triangle at all. Can be right, but it doesn't have to be. These two are pretty much the same because in the last one, ASA, remember the S is included, and on this one, the S is not an included side. But if we have two A's, we actually have the third doing the 180. Okay, so I am going to show you the proof of the law of sines because it is pretty easy. If I look at the left triangle only and do the sine of angle A, it's H over B. If I solve that for H, I get H equals B times the sine of A. If I do it for the right triangle, sine of B is H over A this time. If I solve for H again, I get H is A times the sine of B. So using the transitive property, if I take those two and set them equal to each other, I'm going to get B times the sine of A equals A times the sine of B. That's one version of the law of sines. If I drew the altitude to side A or side B, I would get another version, just kind of replacing those A's and B's with either A and C or B and C. So now you can rearrange this so that is a little easier to remember. If you divide both sides by A and divide both sides by B, the little b's cancel, the little a's cancel, and we get sine of A over A equals sine of B over B, or you could use the reciprocal, doesn't matter. So ultimately, this is going to be the law of sines. It is only going to work for when triangles are an AAS situation or an ASA situation. So we really have all 3 angles because of 180 degrees in any one of the sides. If it was an SSS situation, just to show you why it doesn't work, I don't have a full ratio, right? So that's why SSS wouldn't work on this one. Okay, so for our first problem, you never have to worry about anything either on this. It's kind of straightforward. You get an answer, okay? So I'm going to draw a triangle. Angle A is 48, B is 36, and little a, remember little a opposite big A, is 10. So the first step that we're going to always do is find the last angle. So 48 plus 36 plus C is 180. Now you do want your calculators for this, and you want to make sure you're in degree mode. So if I take those and subtract them from 180, I'm getting angle C to be 96 degrees. So now I'm going to do sine of 48 over 10 is sine of 36 over little b, and then sine of 96 over little c. So I'm going to cross multiply and solve. I get b times the sine of 48 equals, 10 times the sine of 36. Divide by the sine of 48 on both sides. Put that in my calculator. Sine of 36 times 10 divided by sine of 48. I'm getting b is 7.91. So now I'm going to do the same thing with c. I'm going to cross multiply these two. I always like to do the one that I'm given. So c times the sine of 48 equals 10 times the sine of 96. C is 10 times the sine of 96 over sine of 48. So C is going to equal, do that in my calculator, 13.38. I'll just put 13.4. Now, here's the best part about these, is you really can check yourself on everything, okay? So if I take those answers that I just got, 7.91 and 13.4, I can check myself. So in my calculator, if I do sine of 48 divided by 10, I'm getting a decimal relationship of 0.743. So then I can check the next fraction. Sine of 36 divided by that 7.91. I get the same approximate decimal. If I get sine of 96 divided by 13.4, I get about the same decimal. So I know I'm correct. Another thing that you can look at is large angle, large side, small angle, small side, medium angle, medium side. All right, so it's kind of silly not to check yourself. So it doesn't matter whether it's AAS or ASA, you do the same way. So let's have you guys put me on pause and try this one. Okay, so to solve it, B is 72, little b 13, C is 48. So angle A. Angle A is going to be 180 minus 72 minus 48. That's going to be 60 degrees. So I'm going to put B in the middle this time. Sine of 72 over 13, sine of 60 over little a, sine of 48 over little c. So cross multiply and solve, right? 13 times the sine of 60 divided by sine of 72, getting 11.8. Same thing for C, 13 times the sine of 48 divided by sine of 72. I'm getting 10.2. So utilize that as a check. Okay. I'm not able to pause or stop it, so that should be the end of this lesson for AAS and ASA. I'm just trying to get it to stop.